We're talking about simplifying fractions, but first I need to know this little term right here, ratio. Have you guys ever heard of the word ratio? Yeah, does anyone know what a ratio is? What's a ratio? Someone said, oh, go ahead, Josh. That's exactly what it is. A ratio is a comparison of two numbers. That's all you need to know really for a ratio. And it could be more than two numbers, but for our purposes, two numbers is good enough. A ratio is just a comparison of two numbers. Have you ever seen comparisons of boys to girls? Like number of boys to number of girls in a class or in a school, or the number of cheese pizza slices and pepperoni pizza slices, or the number of assists to turnovers, or shots made, shots missed. Okay, have you ever heard of these ratios before in any context? I hope you guys have. Yeah, okay. So it's just comparing two numbers. And you can write it in many ways. I'm going to use the numbers 2 and 3, okay? I'm using these two numbers. The first way I'm going to write it is 2 to 3. That's how you can show a ratio. You write the number, and then the word 2, then the other number, 2 to 3. Pretty basic, I hope. Another way to write it, and it's the same thing, would be 2 to 3. So that little symbol with the two dots is called a colon, which is similar to that clock that when you read it digitally. 2 to 3. That's how I read that. Another way to write it would be 2 to 3. That looks familiar, right? What is that also known as? A fraction. Good. And there's a fourth way. Does anyone know what the fourth way would be? What's the fourth dimension of ratios? Yes, ma'am? Oh, okay. Actually, I wasn't thinking of that, but that technically is the way you could write TWOTOTHREE. Okay, you could do that, but there's another way. I guess a fifth way now. Thank you, Sarah. A fifth way. Davis? That's it. 2 divided by 3. That's the fourth way of writing it, out of the main ones. Which one do you think out of these 4 ways is the most commonly used ratio form? And it's one of them. Nick?
2 divided by 3?
Okay, he says 2 divided by 3. I would say that would be close, but not the most commonly used one. Cole?
You said for ratios?
For ratios.
2 to 3?
Sorry, which one?
2 to 3?
Oh, the first one, 2 to 3. Okay, that one is a close second. And so you're getting there. You're getting there. Sarah? It's the fractional form. This is the most commonly used one. By the way, last year, for example, did you guys deal with fractions a lot? Kind of. Some of you said yes. Some of you said kind of. Some of you are like, I got enough of it, Mr. A. And some of you are like, I don't know, kind of, I guess. I don't know. Or some of you are like, did we talk about fractions? And I hope that wasn't you. But yeah, it's fractional way. Every time you talk about fraction, you're also talking about a ratio. That's just a common, not a common fact, but that is the fact. Okay, this is the way you look at ratios. You're comparing 2 to 3. All right, all that being said, I need you to get this important fact down. This is what the whole lesson's about. Ratios are written, and I'm going to give you a key word here, in simplest form. And I hope that's somewhat familiar. If not, we'll definitely go over it. In simplest form, when the GCF, and we saw that yesterday, right? What's the GCF stand for? The greatest common factor. The name says it all. Okay, nice. There you go. So you're getting, wait, math is in science? And science is math? No, that can't be. There's a giant wall between us. That's not possible. I know what happened. That vent, it carries information through it. Oh no, I knew it. The invasion of science. Sorry. The GCF, the numerator and denominator. I got carried away in my thoughts. I apologize for that, guys. I do that. But when the GCF of the numerator and denominator is a big, fat 1. Have you ever had what we call deja vu?
Yes.
Yeah, I had that. I've actually had it sometimes with the same thing. Like, I had deja vu about this a while back. It's the same thing. This is weird. I have deja vu right now. When the GCF of the numerator and denominator is 1. Do you guys remember that from your homework at all? Is there anything that sounds kind of like that? Think of your homework. Numbers 31, 33, and 35. Yes or no? Cole? This means the numerator and denominator are relatively prime. So I'm going to do a little wordplay here. The homework last night primed you for relatively prime today. Prime is not used in the same way in both of those instances. You're like, what did you just say? The homework last night introduced you to relatively prime. Little did you know that's what the whole lesson today is about. Okay? So you're like, isn't that cool? No? Okay. Oh my. All right. Math relates to itself? Now that's strange. Okay, let's look at example number 1. Let's see how we're actually going to use these concepts because I've been doing a lot of talking. Let's do some work here. Example 1, can someone read that for me, please? Murphy, can you read that?
Refer to the application at the beginning of the lesson. Write the ratio of the amount of land that Miss Swivl inherited to the size of the farm to get in simplest form.
Okay, so you're saying, Mr. A, we didn't even read that. Okay, that guy who's smiling, he's smiling for a reason. His wife inherited this giant 1,200-acre plot of forest. So it was 1,200 acres. That's a lot. And in just a few years, he grew it to 1,500 acres. So he acquired more land. Now it's bigger, right? It grew. And he's happy about it. I mean, he's just like, I love this. But I think he's actually more happy because before, and I'm just summarizing what it talked about there. Before, he couldn't care any less about about trees and plants and all that stuff. But when he got that inheritance, something changed. He started thinking more about trees, planting them, conserving them, not making them into paper. So whatever happened in that transformation, he changed the way he is now. So he grew from 1,200 to 1,500. That's Mr. and Mrs. Level. That's it. Okay, yes, ma'am. He's happy.
I have to learn how to find the GCF.
It's actually right here. We're going to do it right now.
Why?
Can
It
you
doesn't make any sense. It's so true.
hold on? Hold those questions. Those are legitimate questions. Can you hold them? Okay. Right now, I'm looking at a comparison of two numbers, right? Isn't it this number compared to that number? And I want to write this in simplest form, okay? So you could say he went from 1,200 to 1,500, which is great, but we want to see a comparison. Before we get to that, yes, sorry, some of you got it, and that's great. I want to tell you right now, I'm going to do this a certain method, and I want you to pay attention to it because you're going to have to do it too, okay? So can you do that? Can you help me out here? Yeah. And help yourself out because this is review for your quiz tomorrow. So if you want help with that. All right, so stay with me here. I don't know what to do. I'm confused. I'm done. So don't tell me what to do. Let me figure it out using what I already do know because we taught this the last 2 days. Okay, I need you to practice by getting the prime factorization of 1,200 and 1,500. Oh my. I'll help you out. 1,200, that's huge. Can I just do 12 times 100? And then I can start breaking that down. Break it down, prime factors. Just get practice. This is review for your test tomorrow. Or quiz. Yeah, I don't want anyone to revolt against me. Okay, so I got my 3, 2, 2. So this is practice. You're going to need to know how to do this tomorrow. So it's good to review it. Okay, how many of you got something that looks like this? It won't be exactly because some of you may have done like 4 times 300. That's okay to do, or 3 times 400. You can do different ways, but what should your prime factorization be for 1200? If you're writing it out correctly, what would your prime factorization be? Chelsea? 2 to the 4th times 3 5 to the 2nd. All right, that's what you should have gotten. Regardless of the branches you have, you should get that. Go ahead and do that for 1500 as well. Oh my. Cruel and unjust punishment here. It's good practice. Can someone give me the 1500 prime factorization? Yes, ma'am, Murphy? 2 to the 2nd?
Yeah,
Uh-huh.
2 to the 2nd
Uh-huh.
times 3 times 5 thirds.
All right. How many of you got that for the second one? Okay, good. So that's what you get. Okay, so we're good with that. And you're like, okay, we practiced that. Fine. What's it for? This is the concept you need to get down, and you will practice this. Now, I know there's an easier way, okay, guys? I'm not sitting here thinking, man, this is, I feel bad for you. No, soon, very soon, you will be able to do it the easy way. But I need you to practice it this way today, okay? So this is what I'm going to do. And by the way, you're not going to get these huge numbers on your homework, but so don't worry too much about that. 1200 over 1500, so 1200 over 1500 can be rewritten as 2 to the 4th times 3 times 5 squared over 2 to the 2nd times 3 times 5 cubed. Right? I'm just rewriting it. You guys okay with that? I just rewrote it. You're like, I hate it. Well, do you see how I got 1200 to get into this? Okay, and do you see how I got 1500 into that? So I'm just putting it in a different form. How about that? This, once you get into this form, now you can do the process we're going to go through. So listen, I'm right now asking the Lord to help me to teach this clearly and for you to have humility. So if we do that together, if we're doing that together, if I depend on Him, you depend on Him, we're going to get this down. So that's how it works. All right. I hope this works. Lord willing. Okay, you guys see that they have common factors? Okay, we're going to cancel out those common factors because isn't a number over itself equal to 1, right? Okay, so let's see here. Looking at the 2's, okay, please look at the 2's. How many 2's do they have in common? So we're thinking like greatest common factor. Cole? Okay, they both have 2, right? They both have 2. So I'm going to cancel out the 2 2's in the numerator and denominator. Ready? Okay. You see here how you have 2 2's? I'm going to cancel that out. So that's what I mean by cancel. Just put a little slash there, and it becomes a 1. You're like, where did that come from? Hold that thought. If I cancel out 2 2's from this top part, how many 2's was I left with?
2.
So I'm going to cancel out this exponent of 4 and make it a 2, right? 2 to the 2nd now. You guys okay with that? So now instead of 2 to the 4th over 2 to the 2nd, it's 2 to the 2nd over 1. Okay, ready? How many 2's were down here?
2.
How many 2's were up here?
4.
Okay, you had 4 and 2. Now, don't they both have 2 in common?
Yes.
So what's 2 times 2 anyway?
4.
What's 2 times 2? 4. What's 4 over itself? 1. So can't I just get rid of those guys? And what am I left with up top? 2 to the...
I couldn't see that.
That's okay. Sorry. Yeah, my pinky. It's not big enough. Okay. Yeah. 2 to the 2nd right here. Okay, look at the 3's. This will be easier, I hope. 3 over 3. What is that known as? Okay, ready? I'm going to do this. 1 over 1. 3 over 3 is just 1. So I'm just going to cancel it. All right? And then I look at the 5's, which is another tough one. I have 2 5's up top and 3 5's down low. So how many do they have in common?
Well, you cross out the 5 to the 2nd power.
Okay, I'm going to cross this guy out, make it a 1.
Yeah, and then you make the 5 to the... Or you just cross out the exponent.
Yeah, you can do two things and you kind of hit it, Sarah. You can cross out the 3 and leave it like that, or you can put 5 to the 1st, right? Which, what is 5 to the 1st? 5. So you can just leave it like that. If you're neat with your crossing out, you're set on this problem. Ready? Not yet. We'll get practice. Don't worry. I'll give you practice. All right. What's 2 to the second? Okay, 4, right? What's 4 times 1 times 1?
4.
Okay, that's what I'm left with at the top. What's 1 times 5? Now, for those of you who did this in your head, wasn't that the reduced fraction or the simplified form anyway? You're like, Mr. I could have done that in my head. Well, congratulations. Now you can do it this way, which will give you practice with prime factorization and will help you later on when this stuff gets tougher. It is not this easy on this homework. It just won't be. Yes, ma'am.
What's the difference of doing like that long process and like just dividing it by 100 with a fraction?
It's not much of a difference because basically what you did is you divided both of these by 300, which is the GCF of the two, and you would have gotten that.
Yeah, I did it like in this one I divided by 100. It was 12, 15, so I divided it by 3 and 4 good. Could you do that on every problem, or is there going to be some that
You could. Okay, yes, you could do your method. It technically works every time, but what I'm trying to get you here is to do it this tough way for this lesson. After that, you can do it differently. You can do it your way or this way. How about that? Because I don't do it this way, by the way. I am not doing it this way. I'm doing it way differently. But I want you guys to understand what's going on up here so that you can work it out easier and know what you're doing. Okay, let's look at another example because I know that is not easy. Let's go to example 2. Oh, thank you, example 2. You are only 12 over 40. That's nice. So these are more the type of problems you're going to get. So you're not going to get 1,200 or 1,500, have to do that prime factorization with big numbers. You won't, thankfully. Okay, but I do need us to practice prime factorization because that's on your quiz tomorrow, isn't it?
Yes.
So isn't it nice to get practice? Yeah. It's overrated. Okay, anyway, just get practice. All right, does anyone know what 12 is with prime factorization? How do you write 12 with prime factorization? Anyone give that to me? 2 to the second times 3. How many of you would agree with that? You're like, yeah, that's it. Okay, some of you don't agree. Okay, that's all right. How do you do the prime factorization? It is correct. How's the prime factorization of 40 written out? 40. Sarah?
2 squared times 5.
Close.
Cubed.
Cubed times 5. Good. 2 cubed times 5. You know what you're going to get better at? You're going to get better at looking at a number and saying, I already know what that prime factorization is. And this is the case. You could write it out if you know it. Like, if you know it, just write it. Mm-hmm. And some of them we're going to see even in our lesson many times. Okay. Any common factors in the numerator and denominator? Any common factors? Josh. Okay. Do you see how this one has 2 2s and this one has 3 2s? So how many are in common? Everyone? 2 of them. So can I cancel out these 2 and make it a 1? And what happens down here, though? Cancel out that 3. You can write 2 to the first, but that is also just known as 2. Anything else that's common? Is there anything common? No. So you're done crossing out, and now it's time to multiply. What's 1 times 3?
3.
What's 2 times 5?
10.
That's your simplest form. That's the process I want you to go through. Will you have to go through this process forever? No. I don't do it. I'm not going to allow you to say, yeah, this is what I do every time, guys. No, I do it the easier way, but I understand this, and I understand it well. And I need you to understand that well, too, because it gets harder, a.k.a. future examples. Okay, let me ask you this here. Ready? Scout. 3 and 10. What's their greatest common factor?
4.
Yeah. How many of you agree the GCF of 3 and 10 is 1? They don't have any other common factors but 1. Good. That term is... Sarah? Is what? Relatively prime, right? That's the whole goal. You want to get these two numbers to be relatively prime. Are they?
Yeah.
Simplest form.
Yeah.
Simplest form. Okay. Let's do some more examples because I know some of you need more practice. That's cool. Go to page 198, and we're going to do number 6 to start off with. Number 6. Okay, it wants me to take 6 to 10. And it wants me to rewrite that as a fraction. I don't know how to write that as a fraction. Good. 6 over 10. 6 over 10. And then it says, if it is not in simplest form, write it in simplest form. And I need you to do it with the prime factorization just for today, guys. Not forever. Okay. Swivl, did you catch that? That emotion I just gave? I hope you did. Okay. Does anyone know what the prime factorization of 6 is? Rachel. 2 times 3. That's it. Just 2 times 3. And 10. 2 times 5. Good. All right. Are you guys getting better at prime factorization? Yeah, I think some of you are like, you're becoming good to automatic. Got it. That's great. That's what we need to get to. This is going to apply later on. It will apply later on. I want to help you out, even now. Even if let's say this, and I hope this never happens. I get sick, I can never come back to school. I still helped you out on something later on. Yeah. And obviously I don't know what's going to happen tomorrow, so let alone what's going to happen next month. But I want to help you out for then. And I want to help you out for next year and the year after that. Even if you might not be my student anymore, which will be sad because I'll miss you. Anyway, is there a common factor here? Is there a common factor here? What's common? 2. They both have 1, 2. So what's 2 over 2 also known as? 1. So doesn't it just cancel itself out? Okay, what's 1 times 3? And 1 times 5? That is your simplest terms. Okay, you see how easy? I want you to go through this process. Mr. A, can't you just... didn't I answer that already? Did you hear me on that? Okay. Let's do number 8. So please don't just give me the answer. I need the work. So this one's 20 to 100. Can I write that as a fraction? Yeah. Not simplest form. Just give me a straight fraction, Parker. Not simplest form. Yeah, just straight up 20 over 100. That's it. And yes, there are easier ways to do it. Yes, I understand that. But I need you to get it with the prime factorization. So does anyone know what 20 prime factorization? Look at you guys. You guys get this here. Yes, Rachel? 2 to the second power times 5. Now, how many of you almost did it automatically? Like you kind of just... Okay. Does anyone know what 100 prime factorization is? Peter? He's doing his head.
2 squared times 5 squared.
Okay, 2 squared times 5 squared. Mr. A, we're doing a lot of things in our head. What if we can't do it in our head? You can work it out off to the side. That's okay. That's totally okay. But you should be able to get the prime factorization. Oh my, the party's going on over there.
Yes.
The last class was a lot more lively than that. Okay, but
we've already watched
yes, so that's thankfully good. All right. Any common factors here? Let me ask, how about Mandy? Any common factors?
2 to the second power.
Yeah, 2 to the second power over 2 to the second power is a big fat 1. I like that. Okay. Is there anything else that's common? Annie? Anything common?
5.
Yeah. This has 1, 5. This has... So I'm going to cancel that guy out, make it a 1. Cancel this exponent, and I can make it a 1 or just leave it alone. You can leave it alone. I leave it alone. So what's 5 over... Sorry. You have 1 5, 2 5s, right? So one of them cancels out here. One of them cancels there. So you're still left with a 5 down there. What's 1 times 1? What's 1 times 5? That's your simplest form, excuse me. Yes, you could... I think I'm done. You can hear Swivl say it if you look at the YouTube video. Oh, you guys are anxious, aren't you? Example 3. Oh, you'll get it. We have this last concept to go over. Example 3. That fraction is called what type of fraction? It's a special type because it's different than the ones we've looked at. Josh?
Algebraic.
Algebraic. Why in the world, Sarah Harris, would it be called algebraic? It has variables. That's why it's called algebraic. So nothing special about it. So here we have 16x squared y cubed. That's a terrible 3. Y cubed over 12x y to the 4th. Okay, so here's my expression. What do I do? What do you think I've done in the last problems that I should probably do on this problem? Yeah. Just get the prime factorization of it. Does anyone know what 16 is? Prime factor. Yes, sir. Cole? 2 to the 4th. And then what do you do with those those variables again? Do you remember what to do with the variables? How do you rewrite those in prime factorization? Laura, do you remember? How do you write that? Take a guess.
The variable?
The variables, yeah, for the top up here.
X times
And then times.
times y times y times y.
Isn't that fun to say? Y times y times y. Yeah. Okay. No. Tough crowd here. Tough crowd. Okay. And then does anyone know what the prime factorization of 12xy to the 4th would be? Just give it all to me, Chelsea.
2 to the 2nd times 3 times x times y times y.
Okay. All right. Just deal with the number. Remember, didn't you guys come into the class this way? You came in and you looked at it and said, "This is hard, Mr. A." And I'm like, "Are you sure about that? Do you know what we did here? Up to this point, do you know what we just took the prime factorization there, prime factorization there. That's all we did. All right, any common factors with the numbers, and tell me how I cancel them. Let's call on Betsy. Go ahead. Numbers.
The 2.
Okay, how many 2's should get canceled?
But 2 of them.
2 of them. Okay, I'm going to cancel this guy out, make it a 1. And then what do I do with him?
You make it into 2.
Make it into a 2, because there were 2 taken away or canceled out. What about the 3? Sorry, 3, you got to stay. Anything with the variables? Yes, ma'am?
1x and 3y.
1x gets canceled because x over x is 1. And then these 3 y's, and does it matter which 3 y's down here? It doesn't matter. Just pick. What's y to the 3rd over y to the 3rd? 1. So that just became 1. That's nice. All right, ready? What's 2 to the 2nd? 4. Times 1 times x times 1.
4x.
That's like a long, wow, that's a long problem. Yeah, it's 4x. What's 1 times 3 times 1 times 1 times y?
3y.
Mr. A, what did you just say? 1 times 3 times 1 times 1 times y. That's a lot of multiplication. Okay, that's what you get. That's not that much. Now, you see the number 4 over 3? Ooh, what's that known as? A fraction that has a top-heavy number. Improper. In algebra? In algebra? I like improper. You can, the reason we're going to leave it like this is because to write it properly, you would say 1 1/3 x over y. And that's tough to understand. 1 1/3 x over y. This is what I want for your answer. That's cool. You can keep it like that. Yes, ma'am, Rachel.
So why wouldn't you cross out?
Wait, y or y? Oh, go ahead, Rachel. I think I got you.
Why wouldn't you cross out 1y and then 1x? Like for the bottom, why wouldn't you cross out 1y to the top? Why wouldn't you cross out 1x? So you'd have like, do you know what I'm saying?
Not super, but okay. You see how I cancel out these x's? That's 1 over 1. There's no more x's to cancel. X stays up there. I could have done this y with that y, and that y with that y, and that y, right? But it's all going to be a big fat 1. Are you saying do it individually, or?
So at the top there's 3y, and at the bottom there's 4y. So why would you cross out 1y so it'd be equal?
Can I come back to that question?
Yeah.
Let me give everyone a problem to see if they get it, and then I'll kind of investigate that question. I think it's a good one. I'm having an error in my thinking. Okay, I want you guys to try on page 198, number 15. I want you to show me that work on number 15. And you need to simplify or write in simplest form 11t and 120 over 121t squared. So try it out. Okay, sorry, Rachel. Go ahead and explain it. So here's your work.
Okay, so if you were to do like that, and then have 4y's here, why don't you just cross out one of the y's so equal?
Oh, I see what you're saying. Because what's going to happen is you're going to end up, let's say you everything's canceled out. You're going to be left with 2xy to the third over y to the third. You're going to be left with that fraction, which is true, but is the GCF of those two numbers 1? And the answer would be no. They both still have a y cubed, so you'd have to get rid of that. So your goal is to get rid of any common factors so that your GCF eventually becomes 1. That's your whole goal. That's a good question. Okay, yes? Are you okay?
Yeah.
Sorry. If it hurts a little bit, let Miss Clemens know, because, yeah, that hurts. Okay. Okay, prime factorization of 11t is 11 times t, right? Because 11 is a prime number. Can't do anything with it. What's the prime factorization of 121t squared?
121.
Parker. Yeah, 11. Yep, times t. All right. So you're looking at it saying, okay, are there any common factors? Yeah. Don't both of them have at least 111? So that crossed out becomes 1. I'm going to cross that guy out. And then they both have a t. So you should have been left with 1 over 11t. How many of you got 1 over 11t?
After I was done computer second.
Okay, good. You're getting it. All right, and then last one. If you can get this one, you're good. You're very good. Number 16. Last one. 16. X z squared over 16. Sorry, yes, whatever I wrote. 8z squared over 16z. Okay, that up there. Can you make that in simplest form using prime factorization? You have it? Okay, hold on to it, and I'll write the homework on. You can get started with that, but I have a special message. So you're going to have to hold up just a little bit to get that message. Special announcement. All right. Give you a few more moments for that. What's the prime factorization of 8z squared? I'll give you some time. What's the prime factorization, Sarah back there, of 16z? Say that again, 2 to the 4th. That's okay. Yeah, 2 times 2 times 2 times 2 would give you 16, and then times z. Murphy, 8z squared.
2
Okay, 2 cubed
times z
times z. All right, so here's my prime factorization. Hopefully you got to that point. And Alyssa, any common factors?
2.
How many?
3.
So I'm going to cancel out these 3, and I'm going to cancel out 3 of the 4. Anything else? Matt, do you have any other factors that are common? Like right here. Yeah, Z. Good. Z and Z. Good job. Yep. Yes.
On the 2 to the 4th, why don't you come down there and make the 1 since this one has
Yes, so like changing this to that.
No, so you put like 2 to the 3rd, you cross it on the 1, but on
Yeah, so you could put a 1 right here. It'd be 2 to the first. But what is 2 to the first? 2. So you can take that or leave that one. So yeah, that's a good question as well. All right, what's left up top? 1Z, and you can just write that Z. And what's on the 1Z? As a dad, I'm too familiar with 1Zs now. So anyway, what's on the bottom? What's left on the bottom? 2. Z over 2. Z over 2. Or you could say 1/2 Z. How many of you got that one? Yeah, you can say 1Z. Yeah, 1Z is good because that's the identity property. Okay, I'll help you out. You still have some time. That's your homework up there, but there's a little thing I need to tell you. You have a quiz tomorrow, don't you? Josh, in honor of you. Let's do Friday. So, is it your birthday today? Oh.
It's Caroline.
Yeah, Caroline, we're saying for her.
Oh, you're weird.
Oh my. Okay, go ahead and start.